Hello, my peeps. This Algebra Nation video will cover workbook page 76 and part of page 77. Let's get jiggy with it.
Let's beat that dead. Two questions for you. Which of the following graphs accurately represents the following inequality? So notice this is a linear inequality, and it's already solved for y. It's got y on one side. Let's go through those four questions. This slope is negative 2/3. The y-intercept is 2. So we begin with the y-intercept of 2. If you look, 2, 2, 2, 2, 2. They all got a 2. Okay. The slope, though, is negative 2/3. So the slope's got to be negative here, which if you notice, that goes down 2 and to the right 3. That's negative slope. That's a negative slope. Remember that little study edge tip? Remember, if it makes the letter n, it's a negative slope. These two don't make the letter n, so it can't be d or d. So what is it? Y is, well, solid or dashed. It's dashed, which both of them are, so we're good there. But y is less than, so we would shade below, and the answer is C. So that's how you're going to pick out the correct linear inequality. Let's do that one more time. Let's do the opposite. Let me give you the graph, and now ask you which equation below best represents the graph. So to figure this one out, well, it's dashed. And you notice some have equal to and some don't, which means that I'm going to go ahead and get rid of automatically A and C, because equal to means solid, and these just mean dashed. So now I'm down between two choices here. I'm down between two choices. So is it going to be B or D? So ready? One way to do this is to solve each of these for y, and then go ahead and match it up. We've got B, we have B. 2x plus 3y is greater than negative 6. 2x minus 3y is greater than negative 6. Both of them look like they're greater, so shading above doesn't really help yet. Subtract 2x from both sides. 3y is greater than negative 2x minus 6. Subtract 2x from both sides over here. Negative 3y is greater than negative 2x minus 6. On the left equation, you would divide both sides by 3 to get y is greater than negative 2/3 x minus 2. Divide by 3, divide by 3, divide by 3. But on this side, if you divide by negative 3, you have to switch the direction of the equality symbol. 2/3 x plus 2. So in that case, you know that it's got to be answer choice B, because we had to go ahead and get y is greater, and now this one is y less. But in order to do that, you have to make sure y is by itself. So we were able to get rid of two answers based on solid or dashed, and now we can get rid of answer choice D because we have to shade above, not below. So the answer in this case is going to be B. So again, overall, you have to go ahead and get y by itself. Then you get your slope and your y-intercept, graph them, and once you graph those, remember, begin with B, and then move with your slope. Once you have those 2 points, solid or dashed, above or below.
Ready for a brain break? Don't do this on the EOC. Great call, fake punt. He's wide open. Keep running. Oh, epic fail. Looks like a future Tampa Bay Buccaneer, or maybe even a future draft pick of the Miami Dolphins. No one around him. He could have ran for 50 yards. Ouch. This will be problem number 1 on the left side of page 77. The problem on the left side of page 77.
You've learned how to graph linear inequalities, and in case you haven't, it's the last bit. Now we're going to do a system of linear inequalities, meaning we're going to graph 2 of them. And the whole idea is to find where the shaded regions intersect is the idea. It's where do both inequalities actually intersect. So that's the name of this video, Systems of Linear Inequalities. Here we're going to graph two of them on the same axis, and the goal is to find where the shaded regions intersect. So right off the bat, I want to share with you study edge tip. Start by using two different color pencils or pens or markers or writing utensils to see where the graphs overlap, okay? Let's go ahead and do one of these together. Graph the following system of linear inequalities. So remember what we do. Make sure it's y equals, and hey, it is. The slope is 2. The y-intercept is -3. As long as it's in the form y equals mx plus b, the slope m is the number in front of x, or the coefficient rather. The constant by itself will be the y-intercept. And remember, it's not going to be equal because this is an inequality. So in this case, it is y is less than or equal to 2x minus 3. So to graph this first inequality, we start with the y-intercept, -3, 1, 2, down 3. And then the slope, remember, is 2/1. It's positive, which means it rises up 2 and to the right 1. Now you ask yourself those questions. Solid or dotted or dashed, right? Solid or dotted. Sometimes you hear dashed. So in this case, it's equal to, so it's a solid line. So we draw a solid line. Above or below? So is it shaded above or below? Well, y is less than or equal to. Less than is below, greater than would be above in terms of y. So I would shade below is the idea. Aha. Next one. This is also in terms of y equals. So, except again, it's an inequality we're going to shade. Y equals mx plus b, the slope in this case is -1/2. The y-intercept is 2. We start with a y-intercept of 2. And then from that point, the slope is negative, going down 1 and to the right 2. It's equal to, so that would be a solid line. And y is greater than or equal to, greater than means we shade above. What was the whole idea? What was the whole point? We wanted to know where these two linear inequalities would intersect. Where do the shaded regions intersect? And it would be in this region would be the answer. So imagine if you would, you could possibly see a question where they have like 4 of these graphs and give you all 4 regions shaded, and you have to pick the one that is correct. In this case, this is the region. Again, this would be the region where both regions of the linear inequalities intersect. Let's do another.
Maybe in another video, but not right now.